Hey everyone, welcome back. Today we will take a look to a common coding interview problem, the list interval from LeetCode. I will guide you through the solution step by step in Java. If you are preparing for tech interviews, this one is great for learning task scheduling. Alright, here is the problem. You are given a set of the tasks represented by characters, and each task takes exactly 1 unit of time to complete. However, between two same tasks, there must be at least n unit of cooling time. Your job is to find out the least amount of time required to execute all tasks. To solve this, we need to follow a few logical steps. First, we count how frequently each task appears. Then we use a max-heap or priority queue to allow execute the task with the highest remaining frequency. And in each cycle, we'll try and execute up to n+1 tasks, which includes the task and any idle time if necessary. Let's start with the code. First, we initialize an array frequency to count the occurrence of each task. Since we are dealing with uppercase letters, we can map each characters like this. A, it's 0, B, it's 1, and so on, so on. So it will be just array from 26 characters. Next, we use a priority queue to keep track of the most frequent tasks. The goal is to always prioritize the task with the highest frequency so we can minimize idle time. Here we iterate through the frequency array and add each task frequency into the priority queue. The queue is set up in descending order using comparator reverse order, so that the task with the highest count gets proceed first. Now we get into the task execution part. We will simulate cycles where each cycle is n+1 units of time. Why n+1? Well, in each cycle we can execute up to n+1 different tasks before needed idle time. In this block, we pull tasks from the priority queue, decrement their frequencies, and then add them to a temporary list store if there are more instances of this task remaining. We also keep track of how many tasks we were able to execute. Once the cycle is complete, we add the remaining tasks back into the priority queue. We increment the total time, and if priority queue is empty, we add just the number of tasks executed. Otherwise, we add a full cycles, which is n+1. And finally, we return total time. So let's recap our solution. First, we counted the frequencies of tasks. Then we use a priority queue to prioritize tasks with highest frequency, and then we simulate task execution using cycles of n+1 units, handling idle time where needed. Let's now look to the time and space complexity. Time complexity is O from n, because in the worst case, all tasks must be proceeded, and each task might be in insertion and extracted from the priority queue. The priority queue operation, insertion, and extraction have a time complexity of O log k each. Therefore, the overall time complexity is O from n multiplied by log k. Since k is always 26, log k is constant term. So we can simplify the time complexity to O from n. This is linear time complexity with a higher constant factor. Space complexity is O from 26 or O from 1. The space complexity is mainly determined by the frequency array and the priority queue. The frequency array has a constant size of 26, and the priority queue can have maximum size of 26 when all distance tasks are present. Therefore, the overall space complexity is O from 1 or O from 26, which is considered constant. And that's it. Thank you for watching, and if you found it helpful, don't forget to like it and subscribe for more coding tutorials. See you soon!